So here we are at lecture 2. Normally we only do one of these in a class, but in the summer session we have less classes, so we have to do 2 of them sometimes. All right, so we're going to talk about operating systems and the way they store data. A file system is how you store files on your storage device, which used to be a magnetic hard drive. Now it's mostly an SSD. All right, and this module we're talking about Microsoft operating systems. So the allocated storage space is file areas of storage that are currently in use. So they're part of a file, they have a file name, they have an owner, they have a creation date, and so on. There is also unallocated space on a disk, which is areas of the disk that are no longer used to store an active file, but they often have leftover data from files that have been deleted. This is the fundamental issue in computer forensics. When you delete files from a magnetic hard drive, it does not erase the file contents. It only erases the directory entry, so that file loses its creation date, its owner, and its file name, but the contents of the file are left on the disk, just to avoid wasting time erasing it, and they'll remain on the disk until a new file is written on top of them. So you can often recover deleted files, which is what gets a lot of people in trouble legally, because they try to delete files to erase evidence without understanding that you can undelete files. Yeah?
Can you format the drive?
If you format the drive, this is an excellent question. It does nothing. Formatting the drive does not delete those files either. A lot of people believe it will, but it does not. You have to erase the drive with, you can do it in the Microsoft operating system and command line with disk part, list disk, select disk, clean all, and it will take hours. It has to write on top of every byte on the drive. And you can do that, but it takes several hours. Right, so formatting a drive is maybe like 5 or 10 minutes because it doesn't erase the data. It just cleans up the directory table. So this is a very common issue. Many people believe they've cleaned the data off the drive and they haven't. However, with SSDs, most SSDs now do automatically erase data. So the issue of recovering deleted files is becoming less important as we all move to SSD-based devices like my Mac and your cell phone. Magnetic hard drives are no longer that common for consumer devices. All right, so anyway, files are stored all as numbers on the computer, zeros and ones. A byte is 8 bits, and a sector is 512 bytes, or 2048 bytes on optical disk, and you can only read and write data in units of sectors. So if you want to save a notepad file with 1 letter in it, that only takes 1 byte, but you have to save 512 bytes. You can only read or write 512 bytes at a time to a magnetic hard drive. You can't write any smaller unit. So some data is wasted. So you see here, these are the sectors of the hard drive, and then they are gathered together into clusters, typically 8 sectors to a cluster. I think the typical cluster size is 4,096 bytes on a hard drive, and 512 is the cluster. And then you have tracks, which go all the way around. So that's the way it tends to be. All right. So if you have an 800 byte file, it will have to use 2 sectors, and therefore it will have file slack, which is extra bytes in the sector beyond where you've written. So there are various parts of leftover data on the disk. The most important part that matters is complete files that have been erased. If this blue track was used to store a file like an image, and then I deleted that image, the image data would still be there. And until I write another file on there. So if you run one of our forensic tools like Autopsy, the tool we're going to use in this class, you could recover that image. And that's the most important data, is where you have a whole file left over that's been deleted. However, technically there's a little bit of data left from cluster overhang and such. If I stored something here that was 2.5 clusters in size, 2.5 sectors in size, there'd be half a sector here that might contain a few bytes of something from a previous file, like a Word document or something. That's usually useless. You usually don't have enough there to find anything, but technically there's some data there too. Like I say, there's quite a bit of leftover data on the disk, not that you can find if you hunt for it with a forensic tool, that people don't often realize is there. All right, so there's platters and read-write heads storing the data with magnetism on the disk. Looks like this. All right, so a cylinder is the same track number on every platter. So you'd have the top side of this platter, and then the bottom side of this platter, and the top side of the platter under it, and the bottom side of the platter under it, and that would all be called a cylinder. Anyway, now, the RAM is stored in chips, and when you turn the power off, it forgets within a few seconds. So the RAM is what you use for temporary storage, but you store everything permanently on the hard disk or SSD. However, things that are stored in RAM are also often copied onto the hard drive. This is called paging. And this is because modern operating systems let you run many programs at a time. Now, back when I started in the 80s and the 90s, computers were single processing, they would only run one program at a time. I remember you'd go into a word processor and write your text, and then when you wanted to print an image, you had to close it and open the image processor and print it separately, and then cut it up with scissors and tape it together to put images in a document. There was no way to run two programs at the same time. But of course, modern operating systems can run a bunch of programs at the same time. Like right here, I'm running OBS to stream it, and a browser, and a bunch of other things. And it does that by keeping a separate memory region for every program. However, if you keep opening more and more programs, you reach the point where there's not enough memory to open another program. And there was a time when computers would just say, you're out of memory, go buy a better computer. But they don't do that anymore. Now, if your memory is all used up and you try to open another app, it will just take some of the data in RAM and write it on the hard drive in what's called the page file. That's called a swap file also. It will take some data that belongs in memory and put it in a temporary file on the hard disk to free up memory for a new task. So you can continue to open things even beyond the limit of your physical memory. But they will start to move slowly because it's spending time writing them to the hard drive. The hard drive is 1,000 times much slower, I think 1,000 times slower, much slower than your RAM. So that's called the page file. And so, especially on Windows systems, it writes a lot of strange things into the page file. Yeah?
Can you recover data from a broken CD?
Yes, you absolutely can. The question is, can you recover data from a broken CD? Yes, there was even a contest at DEF CON. They took a bunch of CDs and broke them up and had a contest, and people were able to recover like 70 or 80% of the data by just sort of gluing it back together with fingernail polish and stuff. Yep, absolutely. However, it's difficult, of course. You can't just...
It has to be reassembled, though.
You have to reassemble it, yeah. So it's hard work. But an average person, you can't just put it in and do it easily. But if you're a hacker, you can do it. Yeah. All right. Anyway, so the page file has data. And by the way, this was a very important lesson I learned. I took a forensics course. We had it on campus, and we had brand new computers in the lab. And when the people reached this section, they used a forensic tool and examined the page file on those machines, and they found an email that I had written to my sister 2 years previously on the previous generation of hardware. So what happened, apparently, I used to use the computers in the lab before we all had laptops, and apparently the technician that set up that room imaged that machine as the image to put on the new machines. And so the teacher pointed out, this is really important. If you find something in the page file, or for that matter in RAM, you have no idea where it came from. We found that in RAM. So Windows copies random stuff into the page file, and then it copies stuff from the page file back into RAM in an inscrutable way. So it was copying stuff from years before back into RAM where you'd find it. That was pretty interesting. So that's the problem. Until recently, maybe 5-10 years ago, people would not even bother to collect any data except the hard drive, because any data you get from RAM, or from the page file for that matter, does not have a timestamp and an owner. So you don't know when it was put there, and you don't know who put it there. So they'd say, well, it's useless. I can't prove anything from this. But now, it turns out to be very important, especially for incident response, to get that data, even though you can't easily tie it to who put it there. Anyway, all right.
What tool did they use to look at the page file?
Oh, you can... Autopsy is what we're going to use. And Autopsy can read the page file. It can also analyze RAM, too, to some extent. The other tool people used to use was Memorize, and there were other ones, but Autopsy now includes that. We're going to use an all-purpose tool like Autopsy, which is basically a free imitation of EnCase. It's not as powerful as EnCase, but it's pretty good. And good. All right, so you control the page file up here in the Advanced System Properties. There are page file settings, but you normally don't mess with them on Windows. You leave it at the default. Yeah.
Is it possible to only use the RAM and say, I don't want to write to the page table?
People often ask this. They ask questions, can you get rid of the page file? On Windows, you cannot. As far as I've been told, you shouldn't. It'll not work. On Linux, you can. And sometimes people do for servers. You have a server doing just one thing, like a database server. You can, in principle, design it without a page file. I think Red Hat can do that. But it's not common in either case. But I don't think there's any way to effectively get rid of it on Windows. Good questions. All right, so then you need to know different numbering formats for any kind of computer work, and in particular in forensics it comes up more than others because if you really want to know what's stored on a device, it's best to just look at the raw device. And in order to look at binary data, you typically have it in hexadecimal. So everything is stored in hexadecimal, and let's see if this ASCII table is going to open. Yeah, so for example here, if you want to see letters, here's symbols like plus is a 53, let's see, that's octal decimal, okay. Here, a 0 is 30 in hex, which is 48 in base 10. And we'll do more of this a little bit later, but the point is, every character is turned into numbers, and this is the standard table, so the digit 0 is 48, and hex counts by 16s instead of 10s. So 3 times 16 is 48. So hexadecimal 30 equals base 10 48. And we'll talk more about binary as we go ahead. But everything, images, letters, and everything is just turned into numbers. The only thing a computer sees is numbers. All right, and now, in order to tell what kind of file is stored, header data and footer data is applied to most files. So if you have an Excel spreadsheet, it starts with certain values at the start of it. A JPEG always starts with FFD8 and it ends with FFD9. And these are header and footer images. And so when you recover data, say deleted data, if you have deleted data you find in the sectors, you don't know the file name, so you don't know the file name extension. So you don't know if that data is text or a video or an image or a program, but you can tell from this information by the headers and footers that are put in files. And this process is called file carving, taking a block of data and finding the files in it from headers and footers. And it's another thing Autopsy does for you automatically. So when you boot up your machine, it starts with the power off, so the RAM is empty, but you need to fill the RAM with data. So you start with the kernel. The kernel is the part of the operating system that must always be in RAM. It's a small thing that has the essential operations of the computer. And so when you boot it up, it executes the basic input-output routine, which finds some device containing the operating system, like a hard drive or a CD, and then bootstraps the operating system from that. These days, it typically is using this thing called UEFI, is the more modern system replacing BIOS. All right, the master boot record is the first sector on the hard disk, and this contains information about the partitions on a disk. It tells it where to look for the other data on the disk. That contains the master partition table, and the master boot code, and the disk signature, and the end of sector marker. And we aren't covering these in much detail in this class. We go into them in great detail in the malware analysis class. So Windows supports a lot of file systems. There were some FAT versions and then NTFS. All the FAT versions are essentially obsolete. They're only used for things like floppy drives, which are also pretty much obsolete, and thumb drives. Thumb drives are sometimes formatted with FAT. All modern versions of Windows used NTFS, the new technology file system, invented for Windows NT in 1993. That's the new technology file system. So here's the various versions of FAT. exFAT is still used sometimes for removable drives because Macintosh understands it. I think, anyway, all the versions of FAT are pretty bad because they do not support journaling. If you ever used Windows 98, if you're old enough, Windows 98 would crash, and then when you rebooted it, it would spend a half hour saying, recovering lost files, as this thing crawls across the screen, because it didn't do journaling, which means if it was in the middle of doing something, like writing to the disk, and the operating system crashed or the power went out, when it booted up again, it wouldn't remember what it was doing. So it would look and find these partially written things on the disk and not know what they were. So it would spend a long time sweeping them up and putting them in the root of C with names like file 000, file 001, file 002. That was the recovery process that happened. And to fix that, they added journaling to it. So now every time your operating system is doing anything, it writes down what it's doing. It says, I'm copying a file. I'm copying the first sector, the second sector, the third sector. Blam, the power goes out. Then when it boots up again, it looks at the journal and it knows what it's doing and it can pick up where it left off. This greatly decreases the corruption caused on a disk by power failures and the operating system crashing. And NTFS provides this. It also, so it has, that's the journal is the log file in the log file here. All right, it keeps track of what it's doing all the time so it can pick up. It also has alternate data streams, which I think is unique. This is the only Windows feature I know that was added for compatibility with Macintosh. Apple was first with media, like music and movies. And if you bought an album, they would have to have not only the music sound, but also the album art and the album liner notes. And so there are multiple streams of data tied to a single file name. Those are called alternate data streams. You can store multiple contents attached to the same file name, and Windows has this feature too. All right, so the master file table has the metadata for files and folders, which is all the extra data to record what it is, like the file name, the permissions, the owner, the time it was last modified, and so on. It gives you 1,024 bytes to record each one, and it has a lot of timestamps. They can be modified, but some of them are easier to modify than others. So people that try to hide their evidence by manipulating timestamps, which is called time stomping, often create inconsistent timestamps where the easy ones have been changed, but the hidden ones are not changed, and you can catch them that way. All right, there's also a prefetch folder. The prefetch folder, this is why I mentioned computers are recording everything you do to a ridiculous extent, but not because they're trying to spy on you. The prefetch folder, see, here's a fundamental problem with computing, is you have fast devices and slow devices connected together. If you poorly design a computer system, the fast device will be waiting for the slow device to do something, and they try to avoid that. So, one thing that happens, you boot up your machine, you open up something like a web browser. You then read a web page for 5 minutes. The computer is not doing anything. Well, it could just be waiting for you to tell it what to do, but it would be a whole lot better if it guessed what you were going to do next and prepared for that. That's what Windows does. The last 128 programs that have been launched are stored in the prefetch folder. So when you're not doing anything, the computer is loading up those programs in case you want them again, because since you used them recently, you're likely to want them again. And this is the main reason why it tracks everything you do, to try to prepare for your next move. So it keeps track of what documents you've opened more recently, so you can easily open them again. And so the prefetch folder, we'll examine this. It's very handy for forensic examiners. It lists the last 128 programs that have been launched and when they were launched, which is very nice. All right, so here's what it looks like. You have these PF files, prefetch files. They're binary files, but you have to read them with a special tool. But again, Autopsy can do it. Then there's superfetch files, which are not that important, having to do with a trick to get more memory that turned out kind of misbegotten in Vista. Yeah?
Just a general question, is most of the content going to focus on the Windows file system, or?
Yes, we'll mostly do Windows, but we will also do Android and iOS in the project. Yeah.
What about like Mac OS?
I don't think we're going to talk a lot about Mac, just a little bit. There are no free Mac tools that are worth anything. That's the problem. All the Mac tools that work are real expensive and proprietary. So when I do Mac investigations, I just write my own bash scripts to get the active data. And by the way, this raises another important issue. There are some people that try to trick you into buying expensive tools like Encase, and they say, Encase will hold up in court. If you don't use an Encase, nobody will believe your data. This is absolutely not true. My forensic examiner I know from Washington does not use any of those tools. He writes his own Linux scripts to do things. The point is, you are the evidence. The human is the evidence. You go to court, you present your credentials, then you explain what you did, and the jury decides whether they can trust you. You can write your own tools. You can write your own scripts. You can use open source tools like Autopsy, as long as you can defend it in court. It is the question, can you convince people that what you did was right? Now, some people are very shaky with their tools. In fact, most forensic examiners consist of a law enforcement officer that has been to a 3-hour vendor training course. And all they know is how to use Encase, and they don't even understand what it's doing. Well, I click on this, I click on that, the report comes out. And that's not good enough, of course, because every tool can make mistakes. So anyway, this is the thing to know. You're not required to use official commercial tools, although most people prefer to, and then they feel like they gain their credibility from the tool. But that's not a very strong forensic examiner. A strong forensic examiner understands exactly what the tools are doing and verifies the results with multiple tools, because all the tools can make mistakes. And then they can explain from fundamental principles what they did. Yeah?
For that forensic examiner, you're referring to what language did you write in? Is it PowerShell, Bash?
I think mostly Linux, Bash and such, but probably PowerShell too by now. But I took his classes before PowerShell.
Nothing low level, like, or lower level assembly or?
No, I haven't heard of anybody using assembly for forensic examination. There are some people who are experts in assembly, but that's not very commonly used anymore. Typically, just like a command line tool like Bash or Visual Basic or PowerShell is the level you have to go to. You're not usually trying to read it at more level than that.
You mean level you have to go to good enough to report in a court setting?
Yes, here's another important issue. Your tools, your processes do not have to be perfect to go to court. For example, there are cases where you have like a cell phone with SMS on it and you don't have the right tools to connect it all. There have been cases where a police examiner just took a photograph of the screen and then paged to the next message and took a photograph and took another. Now, you don't get all the data that way, but you get some data and it's evidence. Remember, the real evidence is the human testifying. So you can do an examination, and even if you don't find everything, whatever you find counts, and you can explain your process in court. And often you cannot do the perfect thing, which would be to somehow get every bit off the device. So that's why I say I've used things like just write a bash script to get what files I can get off a Mac and call it a day. It depends on what kind of investigation you're doing. The perfect thing, of course, should be to get every bit of data recorded perfectly and analyzed perfectly, but you often aren't able to do that within the practical limitations of your situation. Now, if you're at a corporation, they only let you use official company machines and they have the right tools for those machines. But if you're a police investigator, it's the worst of all worlds because you go to a crime scene and there's all this junk there. Off-brand stuff, foreign stuff, obsolete stuff. Very often, your forensic examiner at a police department really doesn't have the tools to do a perfect job of examining all that stuff, and they have to settle for imperfect processes. But whatever you do, write it down and defend it and don't lie. For example, if you make a mistake and you accidentally erase the data, put it in your report, always admit it, never lie. If you do something wrong, they can yell at you, but if you lie about it, you're in a world of hurt. Like, everybody finds out the cover-up was worse than the crime. I've made mistakes, and you tell the truth. I did this is what happened. Lying will do no good. You admit it if you make a mistake. Of course, it's not good, but that's what you do. The most important thing is tell the truth and explain exactly what you did. All right, shell bags are another thing. If you have a window on your machine, like I've got an Explorer window here that's open to something called Chrome.apps, the operating system remembers which window it is and which view it was and where it is when I open it again. That's what shell bags remember. Shell bags remember where to put every window you've been opening, so it's another record of everything you've been doing. Every window is stored there. And that's in the registry. The shim cache records binaries that you've been using in case they were from an earlier version of Windows and they might have to be adjusted to run on the current version. And so I referred to the Windows registry, which we'll talk a lot more about. The Windows registry is the main place where all this evidence is stored. It's a strange structure stored in about 13 binary files scattered around the Windows operating system and used for almost everything. So file name extensions, associations are here in HKey class's root, which tells it what program to open, like a DOC should open in Microsoft Word and a PDF should open in Adobe Reader and so on. Here's records of what the current user has been doing, like what's in your start button and what's on your desktop. Local machine contains the hardware settings. Users contains every user, including the current user. So in addition to this being a big confusing mess, it's not even unique. The HKey current user points to a subset of HKey users, to the current user. So the data here is duplicating some of the data here. And then there's current config, which is information about the hardware for the startup process. So we'll use this quite a bit later, but this is where a lot of that evidence is stored. And then there's stuff that affects certain features of Windows, like Vista had automatic defragmentation, and this one's important, the shadow copy service. This is a feature that started in Windows 2000 Server, and by Windows Vista, which came after XP, it was now there. This makes an extra backup copies of all your files automatically, which is very nice, of course, because if someone tries to erase data, erase the bad stuff, you can go in the shadow copies and find old copies of files. So it's very nice. Hyberfile contains contents of RAM during hibernation. If you don't want to turn your machine all the way off because you want it to boot up faster, you can hibernate, which takes the contents of RAM, puts it in Hyberfile, and when you boot back, it will just put it back in RAM. So for example, you could have a Word document that was not saved, hibernate, and it will still be there later when you come back. But that Hibr file is a copy of all the data in RAM, so that Hibr file is, of course, useful. Windows 7 had biometrics. It had these jump lists, which are also on the Mac. If I right-click something in the taskbar, it will show me recently used files here. That's called a task list, and that's been around since Windows 7. So that's another list of what you've been doing. Tied to these icons is what programs you've been opening with each of those, what files you've been opening with each of those programs. So again, it records what you've been doing. It has backup and restore, of course. It has encryption, which is Microsoft BitLocker. And you can also encrypt portable devices like USB devices. And of course, the registry you mentioned before. We'll talk a lot more about that as we go ahead. Windows does have a log, event logs, that records what's happening on the machine. And there is a lot of information in there, but typically it's not very useful for a forensic examiner because the main purpose of it is to detect when there are errors in the system so you can fix it. But it does have some information there. All right. And Windows 8 added picture password, is not too exciting. Windows 10 moved from Internet Explorer up to Edge, which had some consequences. Added Cortana, if anybody uses it. I think Microsoft now just officially abandoned Cortana. That was their attempt to compete with Siri, and nobody ever cared. But anyway, all right. So that's it for this one, and I've got another Kahoot or two to go with it. So let's take a look at that. Mod 2A, all right, good. All right, and I'm going to move this to the left in case the number is cut off. Oh, looks like it's not cut off this time. Huh. Oh, yep. That's screwy. It's not consistent. Well, such is life. Fetch files are basically cache files. I see some questions up here. Yeah, have I ever been an expert witness? No, people have offered me the job. I haven't taken it yet. It is an option. Being an expert witness and writing textbooks are things I might do if they fire me around here, but haven't had that yet. And fetch files are basically cache files. No, prefetch files are not files at all. They're just shortcuts pointing to files. It's just a list of files that have been opened recently, programs that have been opened. And both legal teams do bring in examiners. And in fact, you must specialize in either prosecution or defense. You cannot switch from one to the other. In fact, if you have ever participated in defense at any level, you cannot join the High-Tech Crime Investigators Association. I was sort of horrified to find that out. When I got in, that's what they asked me. Have you ever served on defense? And I said, well, no. People have offered me the job, but I didn't take it. They said, good, because if you had, we'd never let you in, because that means you're on the other side. I thought a forensic examiner is a pure scientist that just finds the truth and it doesn't matter what side you're on, and that is not true. They try to push for one side or the other.
Is anything being done to kind of change that philosophy?
No. I was horrified when I found that out, and I complained, and everyone said, shut up, kid, you don't know how it works, this is how it works. They're apparently just sort of like lawyers. You're on one side or the other.
This has been a field of law.
Oh, yeah.
Since what year are we really getting down?
Oh, well, computer forensics has probably only really mattered since computer forensics only since the 80s, but it's essentially the same as the other forensic with blood splatters and stuff. That's been around forever. But you always have one forensic examiner on the prosecution side and a different forensic examiner on the defense side. So just like lawyers, the two of them argue. That's our system. I thought they were pure and philosophical and above all that, but that is not how it works. I think this is the fundamental American idea. They say nobody's unbiased, so instead just make it clear what side you're on. This is kind of how our news is shaping up. You have news on the right, news on the left. There really is no news in the middle. People have tried to do that, but mostly they find it easier to just pick a side and make it clear what side you're on. That's probably more realistic. If you think you're objective, you're probably just fooling yourself. Anyway. Good. All right. Well, we've got some people. I think we got enough. Let's give it a shot. All right, so which one of these is 512 bytes? That is a sector. A cluster is bigger. A cluster is a group of sectors, but sector is 512 bytes. All right, what's the first sector on a hard disk? And I think it's the same for SSD, although I'm not quite sure. That is the master boot record, the first sector. That tells you what partitions are present on that disk. All right, what does Windows 11 use for a file system? NTFS, used by every version of Windows for the last couple of decades. Microsoft promised for a long time to make a new, more advanced system, but they gave up and just stuck with NTFS. All right, what artifact records recently executed apps? Those are the prefetch files we talked about. By the way, you call it artifacts. Artifacts are evidence created usually accidentally. Something created when you do something. They call it, like I say, the main thing that happens in computer forensics is you find things that were recorded in the process of executing your commands, but not intentionally trying to track you. They call these things artifacts. Things that give evidence about what you've been doing, even though they were not specifically, generally intended to do that. All right. They'll have to tell me who they are if they want points. It's a kind sentiment, though. Mohammed. Junk Food John. I remember from last time. Junk Food John. Okay, Mohammed. Good. Let me get it right. All right. Mohammed's a real name. The other people are going to have to give me real names that want points. All right. So I got another one of these. Let's try that. 2B. All right, and I'm waiting to see if the number is visible. It is. Okay. Huh. Strange that it was invisible earlier, but there's always something. If you want to be an expert witness, by the way, you have to make a resume that's like 60 pages long. I've seen them. Because you have to impress them with how wonderful you are. So you list every article you've written, every talk you ever gave, every class you ever taught, every award you ever won for page after page. You want to have, whomp, here are my credentials. I've been doing it for 20 years. I know everything. It's ridiculous. You know, if you're applying for a job, your resume should be 1 page long. But an expert witness, it's the opposite. You want to have, whomp, a giant pile of proof that you're the greatest guy in the world. I was on a jury one time, and the expert witness was testifying in a case where they accused this guy of being drunk, and he had failed the certification exam to be a blood examiner like 4 times. And this came up. That's not a good thing. That doesn't increase your credibility. I was amazed at how totally incompetent he was. He kept quoting the wrong numbers of blood alcohol and then contradicting himself and everything else. It was really a pathetic performance. Yeah. For a forensic examiner?
Yeah.
I don't know. What I do know is defense lawyers will grab you sort of desperately. They often don't have enough money, and they will also throw you under the bus, so you have to watch it. That's why the serious ones work prosecution, and that's the better job. You work for the cops, you work for prosecution. The defense lawyers tend to be sort of slimy and dishonest and fly by night. Not all of them, but a lot of them. So you have to watch it. It's real easy to get jobs for defense lawyers, but they're often not good jobs. It's real hard to get prosecution jobs because the police have to trust you. And usually you have to come from the police or from the military or something for them to trust you. That's why there's a catch-22. Most beginning examiners can only get defense jobs, but if they take them, then they're locked out of the prosecution jobs, which is what you'd rather have. Because the other thing, of course, is 90% of the time the prosecution is right. I mean, the cops don't arrest people who are innocent not all that often. Usually, they're guilty. So the prosecution people feel like they're on the side of the angels, and the defense lawyers tend to be helping guilty people get off. So most people would rather be on prosecution, but it's a hard job to get. But if you get it, it's steady work.
So generally speaking, would you say that defense people are generally more like newbies sort of thing?
More like what?
Like newbies?
Well, some of them are. There are some defense lawyers who are just very broke, so they just try to get any examiner they can. And then, of course, there are the high-priced defense lawyers that get top-notch talent. You can make a lot of money after you get a good reputation. But I never got in the business. I've been trained by people in the business, but I never did it yet myself. I say it's an option. If this teaching stuff doesn't work out, I could always try that. But it's one of my forensic trainers said his sister's a lawyer, and he said, I always tell my clients, I am not going to court. I am never going to court. I know what they do to you in court. I'm not going there. Of course, it's like political campaign. They will tear you to pieces, bring up anything, accuse you of stuff, lie about you. You know, you gotta be tough. You're going to be defending yourself and your credibility against people who are trying to tear it down. So you got to have a strong personality, I think. Anyway, let's try this. All right, so which registry hive has the current desktop settings? It's HKey current user, which it cannot load until you log in. You power up the machine, and it can load things like HKey local machine, which load the hardware, but it doesn't know what the current user is until you log in. Then it adds the HKey current user hive, which has your start button and your desktop and such. All right. Which artifact contains copies of all or part of a volume? That's the Shadow Copy service. Contains automatically generated backups of your files and is therefore very useful for forensic examiners. All right, which one of these encrypts the drive? BitLocker is Microsoft's whole drive encryption. It is considered very secure. However, there is an attack against it called the cold boot attack, where you freeze RAM and take it to another machine and steal the data out of the RAM to break through the BitLocker encryption. And that attack just got improved last week. There's a guy that just demonstrated he built a robot that will freeze the chips on a board and pull them off and get the data out of them, and that is turning out to be extremely dangerous for all these hard drive encryption routines. So, however, if a machine is 100% powered off, that attack won't work. It only works on machines that are like hibernated or suspended. But most laptops are suspended, not powered all the way off. So that's the flaw with this. If they aren't completely turned off, then the key is in the memory somewhere, and there is this attack that can get the data out of the memory. However, it's not easy to do. You need special equipment and hardware abilities, so it's not trivial. But it can be done. All right, which hive contains file name extension associations? Yeah, that's HKey classes root is what it is. All right. Andrew, okay. She shall have rules and CF1212. Okay, CF1212 has won twice. And Andrew is the new one. The other one was CCSF rules is here. Okay, for 6. All right. I recorded those, although some of them I don't know who they are, but if they ever cough up the real name, they can get their points. All right. Let me stop this recording.